So these videos are related to learning about the concepts or different concepts of the water and wastewater operator license exams. In this particular video, we are going to cover the theoretical concepts on the flow and velocity. And basically, there is going to be a follow-up video which will take these concepts and use them in the actual math problems related to these exams. So let's first talk about what is flow rate. Flow rate is denoted by the letter Q and is essentially a certain volume or the total volume of water that is passing by a certain point in a given period of time. So flow rate is nothing but volume per time. So the flow rate Q can be calculated by multiplying what is called the surface area of flowing water by the velocity, which is the speed at which the water is flowing. So let's just first talk more about the surface area of the flowing water and figure out how we are going to calculate that. So when we are talking about a pipe, and if you have a certain flow going through the pipe, and say this is the height of the flow of the water in this particular pipe, so this is H, the surface area of the flow can be calculated using the height of this water in the pipe and the diameter of the pipe. So you essentially need both the diameter of the pipe and the height of the water flow in the pipe to calculate this surface area, which can be used for calculating the flow rate. So, however, in the case of pipe flow exam problems, there is always an assumption that the pipe is flowing full, so that the height of the water that is in the pipe is the same as the diameter of the pipe. So this height of water is the same as the diameter of the pipe, and this surface area of the flowing water is basically the same as the surface area of the pipe and can be calculated by pi over 4 times d square, which is 0.785 d square. So for the purposes of a flow in a pipe, if you multiply 0.785 times d square, it will give you the surface area of the flowing water. And of course, the assumption is that the pipe is flowing full. In the case of a rectangular channel, so say if this is the flow going through the channel and the surface area of this particular flow, which is basically this area, can be calculated from two values. One is the height of the water that is flowing in the channel. So this is the height of the water. And then the other value that you'll need to calculate the surface area is the width of the channel. So for a rectangular channel, the surface area is going to be the height of the water times the width. Now, let's clarify one thing, that for both the pipe as well as the channel, so for the pipe and the channel, it doesn't matter how long those two are. So how long the pipe is or how long the channel is, it doesn't figure into the flow rate calculation. So the flow rate calculation is independent of the length of both the pipe and the channel. And one more thing, specifically in the case of channel, so if this is the depth of the channel, the flow rate calculation does not involve the depth of the channel, only it involves the height of the water that is flowing in the channel. So the depth of the channel is not part of the flow rate calculation. So now let's talk a little bit about the units of the flow rate. So before we go there, let's talk about velocity. Velocity is what? Velocity is basically speed. And the most common unit that we are all familiar in terms of speed, for speed, is miles per hour. So speed is measured in miles per hour, and basically that is the velocity. However, for water flow, the velocity is measured in feet per second. So again, note that velocity or speed is basically the distance, here in miles, here in feet, that is traveled within a certain period of time. So this is miles per hour. So how many miles is covered in 1 hour? And here, in this case, the velocity is feet per second, like how many feet is covered, or how fast the water is flowing, how many feet does the water flow in 1 second. So that is basically the velocity. So when we are looking at the flow rate, so Q, which is equal to the surface area times the velocity. So the surface area is essentially, the unit of surface area is distance square. And typically for water calculations, the surface area is measured in the unit of feet square. So distance square or feet square is the unit of surface area. And then the velocity unit, as we said, is the typical unit that is used is feet per second. So when you multiply feet square by feet per second, basically the unit of flow you're going to get is going to be cubic feet per second. So feet square times feet gives you cubic feet, and then the denominator is second. So the flow rate is essentially volume per time. So cubic feet is the unit of volume, and second is the unit of time. One more thing is that here we are representing flow in the unit of cubic feet per second. There are other units that are utilized in water and wastewater math problems. So the more common ones are, besides the cubic feet per second, there is the GPM, which is the flow rate in gallons per minute. And also very commonly found unit for flow rate is MGD, which is million gallons per day.